So we'll do like an overview of arithmetic series and sequences. A sequence is usually referring to a list of items, and a series is like the entirety of that list of items. Okay, now the words can sometimes be a little interchangeable, but we tend to use the word series when we're talking about the sum of all the terms in the sequence. Okay, so we have two major formulas here. This one here helps us calculate term numbers, so that's what Tn is a specific term number. We're going to say specific because it depends what the n value is. Specific term value. Okay. A1 stands for the first term in the sequence. So we'll give it a little title. First term. So whatever the value of that first term is. D is the common difference.
Come in.
Common difference. And our n is the which term we're looking for. So not the term value, but the term itself. Term number. Okay. This can be a little confusing. The difference between what t subscript n is and what n is. So we've been given this formula here with a whole bunch of definitions and variables. And then these two formulas underneath have to do with summing everything together. You can actually use either of these to do it depending on what pieces of information you have. So what we're going to do is we're going to try to tackle this series, or sorry, say this sequence of numbers. And we're going to try to relate it to this formula here. Out. And then we'll find a specific term. So we'll have what our term number is. And then we'll try to find the sum of it using these formulas here. So there's a lot of stuff we're going to try to cover here. So the very first thing we got to take a look at is this sequence of numbers. It goes 18, 11, 4, negative 3. First thing you pretty much want to figure out, are we going up or are we going down? What do you think is happening? We're going down. So that's pretty helpful. And the question is, we got to figure out if this is an arithmetic sequence. In other words, is it going down by the same amount every time? What's the difference here? This one's going down 18 to 11, gives us a negative 7. 11 to 4, negative 7. 4 to negative 3, negative 7. Okay, great. This value here, this is known as your common difference. So in other words, our D value, that's what we said our common difference was, is going to be negative 7. So that's helpful when we go to use this formula here. We already have something we should substitute in for D. With that being said, we got to figure out what our first term is. Okay. So I'm going to write it out here again. 18, 11, 4, negative 3, and so on. Okay. We already know that we're changing by negative 7. What we want to do is actually have cardinal numbers. Those are counting numbers. Think of like in kindergarten. When you're trying to count the number of items, we start with 1, 2, 3. We're going to give each of these values a cardinal number. So this will be our first term. This will be our second term. This will be our third term. This will be our fourth. And we would just go on and on. Okay. The way we represent that, the value of this, we would say term 1. So T subscript 1 means the first term has the value of 18. Okay. Term 2, which is this one here, has the value of 11. Term 3 has the value of 4. Term 4, I almost counted wrong. 4 has the value of negative 3. The idea here is the cardinal numbers represent this little subscript down here. Okay, so that's the order that they come in our series or our sequence. But their value is different from which number they are. For instance, the first number isn't 1. The first number's value is 18, but that's the first number in our sequence. Okay, so when we have that, we have a common difference here. And what's key is just knowing this first term too. This first term becomes pretty important. So in our numbers or in our formula, they've called it A1. Okay, which is 18. But honestly, you could technically call it T1. I actually think that's a better description of it. Maybe we'll change that to 18. Just the book kind of uses that formula. But T1 is just as good because it relates a little closer to the notation we're using. So if I'm looking for a specific term number, what I need to do to calculate it is I need to know what my first term is, my T1, plus the specific term number I'm looking for. So which one am I looking for? Am I looking for the 3rd, the 15th, the 19th number? and I subtract that by 1, and then I multiply by the common difference. So we actually have a heck of a lot of this information right now. We don't know what we're going to look for yet, our Tn, but we do know our first term to be 18. Because we don't know which term we're looking for, we're going to leave n as the variable, subtract 1. But we do know our common difference. It's actually -7. And those written at the end of a set of brackets, we would still use like a distributive property here if we had to leave that as a variable. So now here becomes our question. Can we calculate, let's say, term 2? Because we already know what term 2 is. We know that T2 is equal to 11. Can we use this formula to prove it? Well, in order to do so, what we're going to say is we're going to try to calculate term 2. So we write T subscript 2. In other words, we're replacing n with the number 2. So in our formula, n is going to change to the number 2. So we have 18 plus 2 minus 1 times -7. Well, I can just deal with my brackets here, and I get 18 plus 1 times -7. 1 times -7 is just -7. So really I have 18 minus 7, which is 11. Did that check out?
Yeah.
That checks out. So we've now built a formula that will help us calculate any of the values in here. So with that being said, this was actually our question. Because they already gave us the first 4 terms, that's easy. Can I calculate the 33rd? Sure, I could just follow this pattern, but I'm going to have to do it like 20 odd more times to get there. Much easier to use our formula. So we're going to say T subscript 33. So we're looking for the value of the 33rd term in the series is 18 plus our n value, which we said is 33 now, subtract 1 times our common difference, which is -7. From here, it's just simple algebra. 18 plus 32 times -7, which I do not know off the top of my head. See if I can figure it out. That's going to be a negative number for sure. That's going to be a 4, carry a 1, 21, 22. I think that should be right, which gives us -206. That's my guess at this answer here, okay? Put in your calculator. Maybe I made an error in the calculation, but that should be the answer. So with that being said, we can now use this formula to calculate the value of any of the terms. We can also, let's say, I've been given a different, let's say they told us that there's a value of a term in here. Let me see if I can get one for us. I'm going to say, my guess is at 1. I'm going to write it out quickly in my answers here, so I can get a good value. Oh, geez. Okay. We're going to tell us that some term value is equal to -192. So let's say they give us that. Some term value is equal to 1, -2 in this series. So that they're asking us is which term is it? We got to figure this out using our formula. So using our formula, what we're going to do is we're going to do some substitution. We use this original formula. We know that Tn is going to be equal to 1 or -192. Our first term, okay, T1 is going to be 18 plus n. N is actually our unknown. We don't know what it is, so we're going to leave it as n minus 1 times -7. What's great is this is still simple algebra. We just have to isolate for n. So we're going to start moving things around and see if we can isolate for n to figure out which term number is equal to -192. I'm going to move 18 over. Then we get 192 minus 18. Well, that works out nicely, that one. This is n minus 1 times -7. That should be a 2 there. I wrote that wrong. I believe this is going to give us 210. So -210. Well, maybe I've miscalculated this number, have I? I hope not. And 1 minus 7. Oh, no, I haven't. Times 7. To get this 7 to the other side, we're going to divide both sides by -7. When we do that, we end up with n minus 1 here. Over here, we end up with 30. Negative 210 divided 7 happens to be 30. So that means our n value is equal to 30 plus 1. And our n number is 31. So the 31st term, which is actually how I created this question, the 31st term, whoops, down here, in our series, so if we were to write this out, 18, 11, 4, negative 3, all the way to the 31st term, the 31st term would be negative 192. We just figured out that piece. Okay, that's using arithmetic series. Now let's say I want us to calculate the sum of all of those numbers up until the 33rd. Okay, so that's this kind of question here. What's the sum of all these terms to the 33rd? Okay, so we're going to write this series out again on the right. Essentially what they're asking us is, hey, you got 18, 11, 4, negative 3, dot, dot, dot. And then we figured out it goes down to negative 206 is the 33rd term. Well, with that being said, we're going to use our sum formula, which said the sum of all these numbers is equal to n over 2. And you can use two formulas. One of them is t1 plus not t2, tn, whatever that term is, okay? The other one is the one I never memorize, is, let's see, 2a. What's the same formula with 2a? Okay. The other one is like this. It's the term value divided by 2 times the first number. I'm actually going to call that t1 plus n minus 1 times d. Let me double check to see that's right. That is correct. Okay. So how do we calculate the sum of all these? Well, we're going to take this information we have. I know that this is t33. I know this is t1. And when we're looking for a sum, we're looking for the sum of the numbers up until the 33rd term. So in other words, the way we'd represent this with notation is we S subscript 33. We're looking for all the first 33 numbers added together, which means our n value is 33 divided by 2. Our first term, well, actually we have that, that's 18. And our last term, well, that happens to be plus negative 206, okay? Here it's just algebra, which is nice. 2 divide 33 is going to give us reduced fraction 16.5, it looks like, I think. 16.5. I like fractions, so I'm going to leave it. I'm pretty sure that's 16.5.
Yeah.
Okay. And then 18 plus 206, negative 206, is going to be negative, let's see if that was 16, that'd be 190, 2 more, 188, I believe. Negative 188. I'm going to do a little bit of reduction here. I can get rid of this 2 by dividing that by 2, which becomes 94. Yep, negative 94. So I'm looking for 33 times negative 94. You're going to have to help me with that. It's going to take me a little bit to solve that piece. And what did we get?
Negative 3,102.
3,102. 102. There we go. So that's the sum of all those together. So even though we started with a positive number, because there's so many negative ones, it essentially gets overpowered, the sum of it. Our other version is this, which we can also use to get to it. So let's see if we've done it correctly. Same idea. We're looking for the sum of the 33 terms. We start with the exact same looking coefficient, 33 over 2. But this time, we take 2 times the first number. So 2 times 18. And we need our term number, which is 33 minus 1, and the common difference. And the common difference in this case was that negative 7. So this would be a version when I don't have that value. So notice we happen to have the value of the 33rd term, but let's say we didn't. We know we want to go that far, but it's actually not in here. I only needed to know my first terms, my common difference, and which term I was looking for. So I don't actually have its value. Using that, we can use this sum formula. This one's going to stay as the fraction. Okay. 2 times 18 is going to give me 36. Plus, this is going to be 32 times negative 7. So we get 33 over 2. This will be 36 minus a large number. 7. Oh, no. Oh, yes, minus. It's multiplication. thought it was addition for a second. 32 times 7. Let's see. That gives us a 4, 21, 22. So minus 224. When we subtract those two, you keep me honest here. If that was 24, it'd be 200. Should be another 12 underneath that. 188. Well, that makes sense. The exact same thing we got before. Good. We're already where we were in the last one. I do a little reduction here. Negative 94. And we end up with negative 3,102. So those are just two examples of how to use those formulas. We did a lot there. Just as a note, we went in here and we solved for unknown terms and stuff. You can do the same with these formulas. If, for instance, they might give you the sum of something and ask you what was the term number value. Or they might ask you what term number was it. And you would choose which of these equations you could isolate a variable in.